Hey guys, last time we talked about binomial distribution. So binomial distribution was when you have some n number of reservation and p is some probability of cancellation, etc. So we were able to get binomial probability using probability of y equal y. The small is number of cancellation, for example, or number of questions you are getting right from out of 20 questions, etc. So when we have this n and p, we can get these binomial probability distributions. So n and p are parameters. Parameters something given from the problem set. So in homework, I ask you what are the parameters. I'm basically asking what is the n and p. For probability, you need to define. In this question, I said p equal probability of cancellation. But you can define P as a probability of not canceling reservation. But you got to be consistent, in other ways. So a probability of y equals small y is number of possible outcome times probability of each outcome. So probability of each outcome is coming from here, this equation. If you are still confused, go back to the previous slide and times this number of possible outcomes. So multiplication of this would be final probability. So let's come back our original question. Initially, in couple lecture ago, I asked you, okay, when you have a 20 question and the probability is 0.2, I ask you what is the probability that you are getting only 2 question right? So probability of y equal 2. So using this formula, what would be the answer? You might want to pause this video using this formula, try to answer it. I'm going to leave you the answer right now, but you want to spend some time because this kind of question can be on the exam, okay? So you can first get this one. That is one. Okay, so P was what, 0.2. So 0.2, and how many Y do we have? A 2, right? So 0.2 to the power of 2. So the potential answer would be ACE because that is the first step. And second step is what? 1 minus P, which is 0.8 to the power of n minus 1, Y. So n is 20, Y equal 2, so it should be 18. Oh, again, ACE. So these are the probability of each outcome, and we need to find this combination. So combination was what? So n was what? 20. So 20 factorial over y was what? Basically 2. 2 factorial times n minus y factorial. So if we do the math, you get the 190, and this is your probability, which should be, it should give you 13.69, etc. So that would be your probability. That's why it was answered in 2 lectures ago, okay? Okay, I'm gonna teach you how to do this in R program. So by now, you should have downloaded your R program in your computer, right? So if you haven't, please download from the website I posted on Blackboard, okay? So you first need to download the R and then RStudio next. So you can do the binomial distribution, something you can do by hand, but using calculator or like R program is gonna be really easy. So I'm gonna teach you the binom. So that is binomial distribution, but this is basically, I'm gonna cover in more detail later, but how it's working is plug in some of the y and n and p in this order. So previously we get what? Binom. Y was what? 2, right? How many observations did we have? 20. I mean, question did you have? 20. What's the probability? That's 0.2. So you drag it and run. Here we go. You get 0.1369094, which was basically that was our slide. So you could get this one by hand, but using program you can get it really quickly. But I sometimes make the questions a little bit tricky so that if you rely on calculator, you might not get the answer. So try to get the answer by hand. Most of the time it will give you the good approximation. So And if you haven't downloaded, please download the program. I will explain the R in detail as we go. And some example is, okay, y, probability of y equal to is neither this nor this. Okay, so the common mistake is two correct answer also implies 18 wrong answers. So it's not only 0.2 to the power of 2, but also this. So there are many combinations of such outcomes. So you should multiply 190 because there are 190 combinations, possible outcomes of each of these probabilities. So 190 times this, each probability would be this final answer. These are some examples, like when you have a smaller sample size, it's gonna more to the left, but as sample size increase, it's gonna be looking like this shape. So I will connect this to the normal distribution later in chapter 6, but for now, just take it into granted now. So because binomial random variable, because we know all the possibility, we can calculate the mean and variance. So mean of y is n times p. Comparing to the previous case, so this is a very important distinction. So binary case, expected value of x was 1, p, and variance of x was 1, p times or minus p. But if we are looking for expected value of y, y is number of something, each binary x equal 1, right? So that is n times p, and its variance of y would be n times p times 1 minus p. So these are some of the formula, but make sure you guys know the difference between x and y, okay? Okay, so if n equal 1, they lead you to the formula for the binary random variable. So because n equal 1, only possible is y equal 0 and 1. So the midterm exam have 20 questions and 5 choices, and we can get the mean and variance. And what would be your answer? Plug in the number. The answer would be, okay, plugging in this number, expected value of y would be 4, variance y equal 3.2. You might be curious whether I can use the standard method we have been using. Of course, you can do that. Of course, you can do that. But this is something more quicker. And I mean, based on some mathematical result, this was the result we are able to get it. And then, okay, assuming the midterm had a different format, 20 questions, but all questions are true and false. And what would be your mean and variance using this formula? It would be like that because it's going to be true and false. So probability would be 0.5 instead of 0.2. So that is only change using this formula. These are the mean and variance. So mean increased from 4 to 10 because p increased, and variance also increased because p gets close to 0.5. Okay, another example. You are a quality engineer, and you know product has a 10% defective rate. That means P equal 10%. As a client, you inspect the product as follows. Like you take 10 samples, and if 9 or more switches are fine, the shipment is acceptable. Otherwise, it's not good. So we need to find the probability of y equal 9 and 10, because the reason why is the case is as follows. So we are looking for, as we said from the question, we said, okay, as long as there are 9 or more, that means what? We are looking for probability of y greater than or equal to 9, right? So that is what? The maximum number is 10. So this would be probability of y equal 9 plus probability of y equal 10, right? So that is your answer, okay? So using the answer, so Okay, let's try to get that. Okay, I mean, I gave you this hint, so you're able to find. So what is the probability of y equal 9 and y equal 10? I mean, you can use the R program to find it, you know. So let's look at R program. So using this binomial, what was y? Y was 9. How many n is 10? What was p was 0.1, right? And we are looking for this one plus 10, right? So answer, I mean, actually we don't have to add them. We can show it separately. That would be this number, and this would be this number. Yeah. Okay. So if you, because I already gave you this, but I prefer you guys are doing by hand, but I just want to give you guys some of this tool so that your life is going to be much easier. But let me show you by hand, okay? Because in the exam, I'm gonna just give you a hint like this so that you can save a lot of time. So probability of y equal 9 would be 1. So because that would be, actually, let me show you in slide down. I probably have this in answer. Yeah. So probability of y equal 9 would be 10 combination of 9 times 0.9. So this is probability of each times this, because I gave you this in the in here. So you just add them 0.39. It's gonna be here. So 10 times 0.39 times 0.1 would be this. And similarly, this is your answer. So what is the probability that shipment is acceptable? So as long as it's greater than y is greater than 9, greater than equal than 9, so summation of this probability will be your answer, like that. So this is another question. Client B has a different rule. Randomly select 5 switches, and if all are fine, except if 2 or more are fine, but at least one is defective, this request an exchange, and if 1 or fewer are fine, request a refund. So let's just make an assumption that P equal 0.5, and what is the probability that client B accept the shipment or request the foreign exchange? So basically, we are you might want to pause this video and spend some time, but we are looking for probability of this plus probability of this, right? I will just leave you the answer. So, but these are the hints. I mean, you can use R program, but sometimes the way of making, I mean, question is R is not always easy because you need some intuition to go through that. So for that reason, I want you to try by hand. So let's y be the number of a fine switch, so offset or exchange if y is greater than equal to. So 2 ways to calculate the probability. So if y is greater than equal to, that means you can just add all the 5. Or since we know the summation of probability is always 1, so this is equal 1 minus probability of y is less than 2. That is probability of y equals 0 plus probability of y equals 1. So 1 minus this summation of probability. So I mean, if you need to do this by hand, this would be much faster because you don't have to calculate this too. So you can calculate that probability of y equals 0 and probability of y equals 1. Therefore, this is your answer. Make sure you try to spend a lot of time on this. Make sure you get the final answer I did, okay? So if you wanna try to do this using R, it's gonna be something like that because we have n equals 5. We are looking for y equals 0, then probability is 0.5. So you can type D binom n 0 because we are looking for y equals 0, comma 5, comma 0.5. If we drag it and run, it's gonna be 0.3, or 3%, about 3%, which is we are getting here, and y equal 1, it's gonna be just do the same thing, but replace it to 1. It's gonna be 15.6%. It's about 0.115. I just rounded up. So subtracting that would be this. So that would be just 1 minus summation of this one, or minus this would be your final answer, which is 81.25. And this, which is equal, basically, using this concept, previous case is gonna be just, what, 2 plus 3 plus 4 plus 5, okay? It's got to be same. So as you can see, those are the same, because summation of probability is always equal 1, okay? So, and these are some more examples. So please take a look at this one. What is the probability that clients will request an exchange or refund? You know, we are looking for this. So if y is less than 5, they're gonna request the exchange or refund, right? So that is probability of y is less than 5, because we are looking for, so you got to read the question carefully. So request for an exchange or refund, that would be this one or this one. So, or in other words, probability of y is less than 5, which is 1 minus probability of y equal 5. I mean, this one is equal to probability of y equal 0 plus probability of y equal 1 plus probability of y equal 2, etc., etc. But that is equal to this. So you can try in R or by hand whether they are the same. So this is another example. Flights and buses accept more reservation than their capacity. This is overbooking problem. That always happened. Suppose you have up to 500 passengers in airplane, but they stored more than that, 520, and probability of cancellation is 10%. And that's why with the number of tickets that have not been canceled, what are the parameters? Parameters are something given. What is N and what is a P? So if in exam, if I ask you to find the parameters, those are something you guys need to looking for. So the parameters are, we are looking for, so why is it the number not canceled tickets? So the maximum possible value is 520. So N should be 520. And Y counts not canceled tickets. So P should be probability of a not canceled ticket instead of canceled ticket. So you should read the question carefully. So because we are interested in why be the number of tickets that have not been canceled, so you should have a probability associated with that. So these are the key points, and you can get the formula to get the final answer. I mean, you can do the same thing using Access and these are something, but I already explained you in our program. So if you guys have any question, please let me know, but otherwise have a good day.